Hello, and welcome to another episode of The Daily Bolt with your host, Dr. Jeff Tilley. Today's topic, the real message of Boaty McBoatface. So, that title probably sounds a little cryptic to you unless you are a climate scientist or have caught a couple of the news reports in the last few days about this scientific mission of this autonomous underwater vehicle, a drone, effectively, operated by the British Antarctic Survey. And the British gave this whimsical name of Boaty McBoatface to this drone as opposed to a more formal designation, which if you go into the scientific literature to the article that's been just very recently published on the data from the mission, you can find that. It's not nearly as interesting or colorful, and it's much easier to talk to you about Boaty McBoatface than a acronym that you probably will never remember. You'll remember Boaty McBoatface. Anyway, the mission of this particular drone was to measure the temperature and the current structure at the bottom of what we call the Southern Ocean, which is the large ocean, basically like a big donut-shaped part of the world's oceans that surrounds the continent of Antarctica in the southern hemisphere. Basically, the Southern Ocean extends between the tip of South America, the tip of Africa, the southern coast of Australia, and the island of Tasmania, and New Zealand, down to the Antarctic continent, which is almost all ice-covered. And there's significant sea ice in parts of the Southern Ocean as well. This particular part of the world's oceans is heavily driven, in terms of its current structure, by strong westerly winds that go through the middle southern latitudes, basically from about 40 degrees south to about 60 degrees south latitude. A large current system that at the surface is called the west wind drift. Now, Boaty was not really concerned as much with the surface waters or the west wind drift or the interaction necessarily with the atmosphere. What it was more concerned about was the deep ocean structure down near the ocean floor. From a climate standpoint, this is a place where there's a lot of formation of very deep, very dense, very cold, so salty, cold water that moves around and is a part of a large global deep ocean circulation system called the thermohaline circulation, which has been found to be a significant factor in the Earth's climate system. So this is all well and good. What Boaty McBoatface found in its measurements along about 180 kilometer track or so along the Southern Ocean is a lot more turbulence in the water than it was expecting to find. Now, turbulence, those of you who have flown in an airplane, you've very likely experienced some sort of turbulence, whether it's just a real minor bump or two, or whether it's a significant up and down and sideways motion of your airplane, and it can often be kind of scary. We're not talking about turbulence on that order of magnitude. The ocean is a much denser fluid than the atmosphere, and so turbulent effects there are relatively small. Nonetheless, just like in the atmosphere, they lead to a mixing of the fluid. In this case, it's ocean water. And when you're talking about mixing of ocean water from the bottom, you can only mix it from higher up above. Now, a typical part of the ocean anywhere in the world has a fairly characteristic temperature and salinity structure. You have the warmest water, and in most cases the freshest water, meaning the least amount of salt, near the surface. You go through a layer in the subsurface called the thermocline, where there's usually a rather steep drop in the ocean temperature. It goes to maybe a few degrees Celsius above zero in the highest latitudes, it actually approaches zero. And then there's a much more gradual decrease in the temperature as you go from the bottom of the thermocline to the bottom of the ocean. There's also a much more gradual increase in the salt content. The thermocline also often has a large increase in the salt content as you go down through it. But again, below, you have much less in the way of a change in the salt content. So what you basically have is the least dense ocean water at the top. You have much denser, colder water at the bottom. If you have more turbulence than was expected, and this is believed to be associated with stronger winds in the atmosphere in the westerlies, having a very muted but still significant effect down at deep levels, then you have more mixing of this water with the water above, which is a little bit warmer and a little bit less salty. This has implications for what this bottom water structure looks like and how it might be changing. And the significant effect that's been reported thus far is the fact that the water would be likely to be a little warmer than it otherwise would be, which would tend to lead to a slight expansion in sea level because the density of water, seawater, will increase a little bit with temperature, so the whole volume of the ocean expands ever so slightly. Now, how big of an effect is this? It's hard to say. Boaty McBoatface sampled a relatively small amount of the Earth's bottom ocean. It's not necessarily a result that you might be able to translate everywhere, but you might be able to translate it around the entire Southern Ocean, and maybe similar effects are occurring in the North Pacific and North Atlantic Oceans as well. We don't know about yet. This is the key message, and this is my point that I want to get to with respect to this podcast. We have lots of people out there with rather shrill voices on various parts of the political and even scientific spectrum that claim the climate change problem is solved. We know everything there is to know about the climate. The scientists have proof, results. And what Boaty McBoatface's mission tells us, because it found something that we didn't know existed in terms of a process or an effect, it's a good reminder that we really still don't know everything about the Earth's climate system. Our climate models, our weather prediction models for that matter, but climate models in particular for this discussion don't have all the information in terms of how the ocean works, the atmosphere works, and all the components of it. We found out something that we didn't know before. And the shrill voices that tell you that the climate problems are all solved are basically full of bullshit. We've just seen this week that we don't know everything there is to know about the climate system. This was an effect that we had no clue even existed. Wasn't in any numerical model, wasn't in anyone's theory, wasn't in anyone else's data. This is brand new information. And this is something that is key to all of science. It is very, 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 very hard to have something be 100% proven by science. As you get new evidence, the theories that we try to use to explain how the world works can be modified. We're going to have to make some modifications to theory to deal with this. We're certainly going to have to make modifications to numerical models that represent the ocean, whether it be in a short-term context or a long-term climatic context. None of our climate models anywhere in the world have the representation of this turbulence and what it might do. So here's something that we don't know. There have been those in the scientific community, myself included, that have not jumped on the bandwagon of hysteria about climate and climate change. Is the climate changing? Yes. Do we have good information on how it will change? Some. Not 100% definitive. This result just proves that point. We keep finding out new things about this world and its climate system every single day. And for someone, whether they're a scientist who's caught up in their politics or it's a politician that thinks they know a hell of a lot more about science than they really do, start shrieking about the world ending in 12 years, I would not be running out and getting emergency supplies just yet. We found out this week there's probably still a lot more we don't know about how the Earth works, and a lot more that we don't have represented in prediction models. So there's still lots of uncertainty out there. Is it reasonably certain that there are changes in climate going on? Yes, but there's always changes in climate going on. It's just a matter of how fast they're occurring and what type of changes they are. The oldest people living on the planet have been around for about 114 to 115 years. There's been climate change through their entire lifetimes. There's climate change through my grandparents and their grandparents' lifetimes. But it's something that, obviously, we're still just learning about. So, if someone tries to tell you, oh, I have 100% proof of this, with respect to climate, or even any scientific point, be a little suspicious. Take it with a grain of salt. Let them show you their proof and their data, and ask them, well, do you think you know everything about the system? And if they say yes, you might come back to Boaty McBoatface. And that's the message that Boaty McBoatface has for us this week. That's all for today's edition of the Daily Bolt. If you like this podcast, feel free to become a patron. Feel free to comment, like, share it, etc. If you're going to be a hater and just, spew vitriol, don't bother. I'll find a way to delete you. If you want to have an intelligent debate on what I'm talking about, feel free to leave a comment, either on Podbean or on my Facebook page under Tilly Weather Associates, and I'll be happy to respond. I might not agree with you, but I'm open to a good scientific discussion. So for now, that's this edition of the Daily Bolt. I'm your host, Dr. Jeff Tilley. Have a good night, good morning, good afternoon, depending on when you're listening, and God bless.